In this video, we're going to look at the basics of quadratic functions, what they are, and then also how to solve a couple of them. There's many techniques to solving these, and we'll learn one today with a certain type of quadratic equation. So quadratics are really x squared functions. They're something x squared plus something x plus some number. So which of these are quadratic? Well, the first one is. We'll just put a little smiley face next to the ones that are. That's A in this case would be 3, B would be 1, and C would be 0. So it's an x squared type equation. This is also an x squared equation. This A is negative 1 here, B is 0, and C is also 0. So that's quadratic. This one, even though it's written in the wrong order, it's not in the standard form, it's still quadratic. A would be negative 1, B is 1, and C is 3. So that is also quadratic. So maybe they all are. This one looks like it is. It's an x squared, an x, and a 6, but there's an x out here. And if we distribute that, we end up with 2x to the third plus 4x squared plus 6x. And this is not a quadratic equation or function. This one is a cubic. It's next to the third. The next one, it looks like we have to do a little bit of multiplying as well. Here we do some foiling. If you remember how to foil, you think of it as like double distributing. Some use the box technique. So we'd go x times x is x squared. Then 2 times x is 2x. And then x times negative 1 is negative 1x. And then 2 times negative 1 is negative 2. So this ends up being x squared plus x minus 2. So this is a quadratic. So let's give that a little smiley face as well. And then the last one, if we distribute that x, we get x squared plus 2x, so that is quadratic also. So the only one here that wasn't quadratic was this one, and although it looked like it at first, if you distribute that x, it's not quadratic. Okay, so quadratic equations are going to look like parabolas. It's going to be U-shaped. And in this case, it has a minimum value. If it looks like this, it has a maximum value. What that means is parabola goes down to a certain point and then it won't go below that. That's the minimum of this parabola. Here it will never go above this one. What happens here is this example would be if x squared is positive. So this one is something like y equals x squared. And it says the coefficient of x squared is positive, so that it might be like 2x squared or something like that. Where here, it's upside down, so that means the number in front of x squared isn't going to be negative. So it might be negative 2x squared, or just negative x squared possibly. Anytime it's negative in front of the x squared, it's going to flip it upside down. Okay, and then the other thing about parabolas, there's an axis of symmetry. Parabolas are nice and symmetric. And so this axis of symmetry goes right through what we call the vertex. This is the vertex here. The axis of symmetry cuts that parabola in 2 equal parts. So this axis of symmetry on this particular example is this vertical line at x equals 4. So the equation for the axis of symmetry here is x equals 4. And our vertex is at 4, 1. And one thing you'll notice when you're looking at axis of symmetries is it's always the x value of the vertex. So how far up and down it is doesn't matter. Since it's a U shape, it's going to cut it right at that vertex, so it's going to be x equals that x value of the vertex. Okay, let's solve a couple of these. So we'll start with some easy ones, and then in later videos you'll look at how to solve a little bit more complicated quadratic functions. So if we're going to solve for x here, first thing we do is let's get rid of this 3. So we divide by 3. It's just like solving, linear equations you did in junior high. So 48 divided by 3, that's 16. And then the opposite of squaring is square root. So what number times itself is 16? Well, 4. But there's also another answer here, because 4 squared is 16, but also negative 4 squared is 16, because negative times negative is positive. So when you're solving quadratic functions, you're always going to have two answers. And that's one thing you have to get used to when you're dealing with an x squared equation and you're going to solve it. You have to have two answers. If you don't get two answers, then you've done something wrong. So our answers are 4 or negative 4. All right, let's look at the next one. 6x squared minus 24 equals 0. Well, let's add 24 to both sides. And this technique won't always work. If there were an x term here, then we'd have to use some other technique, but that's a different video. So we get 6x squared equals 24. Divide by 6. We get x squared equals 4. And if we square root both sides, we get x equals 2 or negative 2, because negative 2 squared is 4. Sometimes you'll see people write this as x equals plus or minus 2. It's just a more concise, you can call it a lazy way to write 2 or negative 2. You just write it plus or minus 2. Okay, one very common example of solving quadratics is something like this, where it says solve for the missing side. So in a triangle, if its letters are A, B, and C, the little b is across from the big B. And so this 12 would be the A side, and the 5 would be the C side. Now, to figure out the missing, this is a right angle here. To figure out the missing side on this right triangle, we'd use the formula a squared plus b squared equals c squared. And one thing that always confuses people is, well, this side's b. No, this side is the hypotenuse. And that's always going to be this one. This is the hypotenuse. So don't get confused on what letters they use on this triangle. This triangle could be any letters that you want at all. But all that matters is the A and the B here are the two legs, and the C is the hypotenuse. So to solve for the hypotenuse, we're going to go 5 squared plus 12 squared equals c squared. Or I guess in this case, we might write b squared. Okay, so let's solve it. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. And then if we square root both sides, we get b equals 13 or negative 13. However, you can't have a negative side length here. So this side is going to be 13 units, whatever the units are on this one. All right. So there's a very common example of when you would use the quadratic when you would solve a quadratic equation using the Pythagorean theorem. And then last one here for today, let's solve this one. So this is just a multi-step situation. We get 4 times x squared plus 7 minus 9 equals 39. So, I encourage you to write this down, pause it, and try to do it yourself. But I'll do it right now. So we do add 9 to both sides. And we get 4 times x squared plus 7 equals 48. Now there's a couple of right things you could do here. One is you could distribute the 4. That's totally right. You could definitely do that. Or what I'm going to choose to do is just divide by 4 on both sides. And those are going to cancel out. We get x squared plus 7 equals 12. And then I would subtract 7 from both sides. I get x squared equals 5. And then if I square root both sides, I get x equals plus or minus. Remember, there's two answers. And then it's just square root of 5. We're not going to punch that in our calculator and figure out what decimal it is. At this point in your math career, you just write it as square root of a number. So it's just x equals plus or minus square root of 5. Okay, so there is your intro to quadratics.